I welcome you all for this presentation. In this presentation, we are just continuing the substitution techniques only, and here we are going to discuss about the Vigenere cipher. This is the overview of this presentation. So far, we have discussed about mono-alphabetic substitution ciphers. In this presentation, we are going to discuss about poly-alphabetic substitution cipher. Under poly-alphabetic substitution ciphers, we are going to discuss about Vigenere cipher. Then I will be giving some problems to practice, followed by summary of this presentation. So what is a polyalphabetic substitution cipher? Monoalphabetic means we are replacing one character at a time. Here polyalphabetic means more than one alphabet at a time. That is the polyalphabetic. So here the relationship between a character in the plain text to the character in the cipher text is one to many. That is the difference between monoalphabetic and polyalphabetic. So why we are going in for this polyalphabetic means this monoalphabetic substitution ciphers are vulnerable to attack. We know different monoalphabetic cipher, what is the disadvantage, all those things we have discussed. So in order to improve the security using multiple cipher alphabets, we are going in for this polyalphabetic substitution cipher. And we can make the cryptanalysis harder with more alphabets to guess and flatter the frequency distribution. So here we are using a key to select which alphabet is used for each letter of the message. And we are using each alphabet in turn also. This is repeated from start after end of the key is needed. There are two categories of polyalphabetic cipher. Two examples of polyalphabetic cipher. One is the Vigenere cipher and another is the Vernam cipher. And in your syllabus only Vigenere cipher is given. So we are only discussing about Vigenere cipher. Those who are interested to know more about the polyalphabetic cipher, you please go through the Vernam cipher also, and then you compare both the algorithms and what is the difference, all those things you can work out if you are having extra time. So coming to the Vigenere cipher, it is the simplest polyalphabetic substitution cipher. The meaning is here we are applying multiple Caesar ciphers. We all know what is a Caesar cipher. It is a base substitution cipher, right? Shift cipher. So there what you did is plain text plus key mod 26 we have written. For one character we did. Here we are having multiple characters. The same thing only applied, but for a stream we are doing. See the pictorial representation here. We are having the plain text that is divided into streams P1, P2, P3, etc. And the cipher text the same number of characters only. That the key stream we are having. Here one keyword is given as a key. So based on that only we have to split the plain text into different streams. And how we are performing the encryption is the cipher text I equal to Pi plus Ki. It is a polyalphabetic, so only here we are having I. So this formula is similar to that of Caesar cipher only. So only here we are using multiple Caesar ciphers. So here the key is a multiple letters long, that is K equal to K1, K2 up to KD. That is the keyword we are having multiple letters. So ith letter specifies ith alphabet to use. So we are using each alphabet in turn and repeating from start after D letters in message. So decryption simply the reverse process only. And here the key stream does not depend on the plain text characters. So this is very, very important. Here key stream does not depend on the plain text characters and it depends only on the position of the character in the plain text. So in the Caesar cipher what we did is for A, in all the places A is replaced with one particular letter only, D. But here it does not depend on the plain text characters. It only depends on the position of the character in the plain text. Okay, that is the difference. Here we are using multiple Caesar cipher, but the key stream does not depend on the plain text characters. So let us see one example. Encrypt the message. She is listening using the 6-character keyword Pascal. The initial key stream is this one. The key stream is the repetition of this initial key stream. So here the plain text she is listening is given. So P's value is we have to map it to the integer for each and every character. So S for A8, H7, E4, likewise it goes on. So for each and every plain text letter we are just mapping it. So So here why the block is given means it is in one color, meaning is the key stream Pascal is coded like this. Here also we are just mapping the alphabet to the integer. 15, 0, 18, 2, 0, 11. So here 15, 0, 18, 2, 0 and 11. So this comes in one block or one stream we are calling. The key stream is a repetition of this initial key stream as many times as needed. And here one thing you have to notice, she is listening. So here we are having two blocks, and the third block we are having only two alphabets. But in the keyword we are having 6 alphabets. But here we are not doing any filling. Simply whatever the characters left, for that from beginning we are just writing. That's it. Only 15 and 0. We are not doing any filling here. So that is the main thing, you have to keep it in mind here. Then we have to use the formula, that is Pi plus Ki mod 26. So that we are getting the C value. Then we have to map this value to the corresponding the ciphertext alphabet. So here we can see that Vigenere cipher can be seen as a combination of M additive cipher, because the whole plaintext is divided into different blocks, and for the block we are applying the keyword and each and everything is performed. All the additive operations are performed. So we are performing M additive ciphers. So what is the size of M? That depends on the size of the keyword. This is one way to perform encryption process using Vigenere cipher. Another method is we can use a Vigenere table or Vigenere table or Vigenere square. So Vigenere square table means here the alphabets are written in row wise as well as column wise. So wherever the cross section is coming for the plain text and the keyword, wherever the cross section is coming, that is the corresponding encrypted letter we have to take it. So here first row of this table has 26 English characters. It shows the plain text character to be encrypted. Row represents the plain text character. And starting with the second row, each row has the letter shifted to the left one position in a cyclic way. So when B is shifted to the first position on the second row, the letter A moves to the end. The first column contains the characters to be used as a key. So column represents the key and the row represents the plain text. So in that way only we have to think. If you do the reverse process, we are getting different answers. So always row represents the plain text and column represents the key. So for a same example, you can work out using the formula as well as you can see the table also, so that we can check the answer. Whether both we are getting the same answers or not, we can check it. So both the method we are getting the same answers only, but here in the table you have to see that plain text in row and the key in the column wise you have to look into. So this is the Vigenere table. Let us see something. What is that? What we did is she is listening is the plain text and Pascal is the keyword. So for the first one, S is the plain text and the keyword is P. So S and P. S you have to look it here and P you have to look it here. So what is the cross section of this S and P? That only we are calling it as which one? The ciphertext. Here you see. So this part is only cross sected. So this value only we are finding. So H. So without doing any calculation, if you have the printout copy of this table means we can directly map it and we can write the corresponding ciphertext. So the same example what we did, that only given. So here first S in the first row we have to look into and P in the first column we have to look into. The cross section is the ciphertext character H. Likewise it goes on for the remaining characters also. So coming to the security analysis of this Vigenere cipher, it has multiple ciphertext letters for each plain text character. So it is somewhat secure compared to the Caesar cipher, and hence letter frequencies are obscured here but not totally lost. It is also vulnerable to attack. Except one time bad, all the ciphers are vulnerable to some form of attacks. So here start with the letter frequency, see if it looks monoalphabetic or not. If not, then need to determine the number of alphabets. Since then we can perform attack on the cipher or crypto system. So all the ciphers are vulnerable to some form of attack, but how long it is the attacker took to break the crypto system, that matters. So I have given you some 3 problems to practice. First one is encrypt the plain text via discovered save yourself using the keyword deceptive using Vigenere Cipher. You have to use the cipher, that is calculation. The cipher text equal to CI equal to PI plus KI mod 26. And second one is you have given the plain text to be or not to be, that is the question, using the keyword relations. Here you have to use the table. So whatever you did using both the method, you have to perform decryption and try to get or retrieve the plain text. So you try to solve these problems. So in this presentation, we discuss about one of the Pali alphabetic substitution ciphers, that is the Vigenere cipher, and we discussed about the security of this Vigenere cipher. Then I have given you 3 problems to solve. So in the next presentation, we will be discussing some other substitution cipher. Thank you.